Welcome to Brain Vision.
So we can draw a diagram of the system. On the edge here, we have the force of friction, and the direction of rotation would be clockwise. So we can say that for part A, the torque exerted by the frictional force would be the torque tau equaling the frictional force times R times sine of theta. Now here, the force of friction is assumed to be tangential to the clay, and so theta would be equaling 90 degrees, which would make the total torque for part A equaling R times the force of friction times sine of 90 degrees, which we know to be 1. And so this would be equaling to the 1/2 times the diameter, 1/2 times 0.12 meters, multiplied by the force of friction, 1.5 newtons, and this is equaling 0.090 Newton meters. This would be our answer for part A. For part B, we're trying to find the time to stop. The time to stop would be found from the final angular velocity equaling the initial angular velocity plus alpha times t. We know that the total torque is equaling the moment of inertia times the angular acceleration, and we know that the final angular velocity is going to be 0. And so we can say that the torque would be equaling essentially the negative initial angular velocity divided by alpha. And so this would be equal to negative initial angular velocity divided by the torque divided by the moment of inertia I. And so this would be equaling negative 1.6 revolutions per second multiplied by 2 pi radians for every revolution. And then this is divided by negative 0.090 Newton meters. And then, of course, because the torque due to friction would be opposite of the direction of motion, therefore the torque would be negative, and then divided by the moment of inertia, 0.11 kilograms meters squared. And so we find that the time it takes to come to a rest would be approximately 12 seconds. This would be our answer for part B. That is the end of the solution. Thank you for watching.